Let me get started. Hi, thank you for joining in. Good morning.
Can you hold on one second?
Today I would be presenting a topic on how to measure test case efficiency. This is a concept that I have been working for some time, and I'm glad I had a chance to present it to you guys. So this is the primary problem statement that we were trying to solve. Okay. We
Can
wanted
you
to
hold on one second? Can you hear
measure
me?
the product quality
This work.
of a couple of products and build uh, a measurable unit which is repeatable, easy to measure, release over release. For us, the biggest challenge that we have been facing is we have been having 10 to 12 products that we release on a monthly cycle, and we wanted something which is easy to measure and something which is repeatable, and we draw actionable outcomes out of it. So the first step towards this is, why do we measure, why do we want to
Can you hear
test
me?
software ability before release? Better quality, better user experience. To sum it up, to release better quality products to the customers, that's the one of the requirements.
Testing.
But
Can you
how do
hear
we
me?
measure the products are better tested? Okay. So what are the, how do we test software quality? Usually we have traditional approach of having unit test coverage, path coverages, different coverage metrics that we produce. All of these coverage metrics is something that we do during the development cycle. When it's been tested, it's still within your boundaries. You have not yet released it to the production. You put in a lot of checkboxes into the system saying we need to have so much of code coverage, so much of automation, so much of different metrics that needs to be measured. But end of the day, we are still unsure whether this, when released, would have a case where we would see zero production bugs. Despite all our religious best case efforts, production bugs is a reality. And we have been able to see that despite the best metrics that have been presented, production bugs, when they hit us, the cost of fixing them is way too high. But the surprising fact about a production bug is, till the time it doesn't, it's uncovered from the field, the actual cost of that bug to fix it is unknown. It could be a just very simple UI issue or a login issue, which cost you way too high, almost 1,000x time, when it gets reported from the production. It could be just a queue issue or a simple line of code change, but when it gets reported from the production, the impact is way too high versus how we would perceive it or detect it much early in the cycles. The best place, by my experience, is to find a bug even before it's coded. We take this reference very seriously. We have had tremendous good results by following this statement. Best place to detect a bug is even before it's coded. And we have used this for bringing in a lot of improvements in our products. I'll talk about it much more in detail in the upcoming slides. So we wanted to have, as I said, our product series has close to 12 products that we track, and we follow a monthly test cycle, a monthly release cycle, and it becomes, we don't have the luxury of time. We have to be in a quick paced format where we measure and we quickly release. If any quality improvement we need to do, it has to be instinctive, instant, and in immediate. The results needs to be reflective in the next release. I cannot have a measurement matrix which would go on for to collecting the data itself for a month. The entire release cycle from conception to the release itself is a 4 weeks window for me. So to measure quality, we came up with a concept which is very similar to what has been followed in trading, stock market trading. In stock market trading, there is specifically in derivative trading. I'm not talking about the equity. In derivative trading, they look for something, or they do a trading which is called as speculative trading, which is you will gauge whether the index or a specific share of a company would go up or down. They call it as a bull run or a bearish move. So based on this, they would then buy a call when it's towards heading towards a bullish move, or they would pick up a negative position when it's a bearish move. Basically, a call and put. If you are familiar with trading terms, this is what they would be using. A call is taken and a put is opted for when a bearish market trend is assumed. They use this ratio, and the whole concept of derivative trading itself is quite vast. That's not the topic for this discussion, but any script or index would have something called as, for a script or equity, it would have a monthly expiry, and for an index it would have, at least in Indian stock markets, we have a weekly expiry. And each of these movements is tracked by something called as option chain. Now, keeping aside all the jargons of this data, what is the option chain of basically what are the open positions for call, what is the open positions for put? They calculate a ratio, what they call it as a PCR, put to call ratio. This ratio, come to this ratio is a tedious task of how we arrive to this ratio. But once we arrive to this ratio gives, what you're seeing on screen is the actually this week's call to put ratio for a Nifty 50 index, similar to any index in the stock market that we see across the board. So this is Indian weekly expiry index, Nifty 50 index, and there is a wide range of this, but on the last column that you would see that I have calculated the PCRs. Now, a PCR of 0.1 to 10 determines the range of the market where it would be for this week. And this has been pretty much where the call writers or the option sellers use this data to operate just on this PCR data. How we landed up in this PCR is a cumbersome math of all the option chain analysis, but this PCR anyone could calculate, because any exchange would give you this ready data available. Now, this PCR is a very simple ratio which gives you accurate, almost accurate direction of the market or the range bound of the market. It's an indicator of where the market stability is, which range it is. I just thought this is the most simplest way to approach or understand the bird's eye view of any concept that we are talking about. Taking inspiration from this, then we start thinking through what could be the easiest way that I could formulate to measure the quality of our products in the shortest time possible. So before I jump into the math of it, let's define some terms. One is in-house bugs. What do I mean by in-house bugs is simply any bugs which are uncovered during the development and testing phase before its release, from the conception to the release. That's a 4-week window for us. Any bug related logged during this duration is in-house reported bugs. Let's tag it as in-house reported. So then anything which is beyond the release date, once it hits its production for us, any bug reported by the customer from that point in time in forward is something which we call it as a customer reported bug. So on the right hand side, you can see the diagram where it shows you the development phase, which is for in-house. The release phase is where the customer reported bugs may come in. Now, regression bugs, for simplicity, regression bugs, I'm taking it reported by Dev and QA also as customer reported. You could opt it. These are two numerical data which gets collected. Now, in-house bugs are available as soon as you are on the last day of the development cycle. But for the released timeline, till what is the timeline that we need to think of before we capturing customer reported bugs? You could think of, if X is released today, in-house bugs data is logged in, but customer reported bugs will be available. That data would be available to you at the first day of X+1 release. So that window is considered for customer reported bugs. Okay. Using these two just simple ratios, I calculate something which I call it as quality volatility. Now, this is very simple ratio that I have come up, very similar to the put to call ratio that I was talking about. Now, the data here is total customer reported bugs divided by the total in-house reported bugs. Now, this is a ratio which gives you, which treats every bug at the same weightage level, irrespective of whether it is a priority 5 bug or a priority 1 bug. So it just looks at the overall count. So it's a simple quality volatility, gives you a sense of direction where it is heading. To make it more realistic, what you could do is you could assign a weightage to each of the bug type that is getting logged. When I show present data, real-time data, it would be far more clearer for you. But for weighted quality volatility, basically you give a weightage of P1 is at a 5 weightage all the way till P5 is a 1 weightage, and then you divide it by the the in-house reported bugs following the same weightage format, and you get a ratio again the same ratio, but it would be a more realistic weighted quality volatility. It would be a far more two-step more deeper analysis of this. Once we are done with this, what we get a quality volatility ratio. What this ratio means, um, at the bottom, you are seeing the 5 products data. This is actually real-time data which we had collected. I have collected the N is the N plus 5 version, N plus 1 to N plus 4 is the release cycles that we had collected data for. Quality volatility ratio is a very interesting number. It could range from anywhere between 0 to the most highest number. How do we interpret this ratio? Now, any range between 0 to 0.2 is a good place for a product to be in. What simply means is if the ratio is coming up to 0.2, for every 10 bugs which are logged by in-house reported teams, 2 bugs are getting reported by customers. Still acceptable. Popular trend by support teams is that they want to have this ratio to 0.08. That's 8% of the count can come from customers. But for simplicity, that's an aggressive best case scenario. But anything to 0 to 0.2% is the ratio, which is fair enough. Anything which is 0.5 basically means every 2 bugs that you have logged in-house, 1 bug is getting logged by the customer. So this gives you a health of overall how the product is performing in real time. Once your ratio starts climbing above 0.5, suppose it hits 1 or above 1, something is seriously wrong with your testing approach. You need to pause new feature development, relook at your test cases, increase coverage. Basically, the moment I hit the ratio of 1 or above 1, customer is logging customer is logging equal bugs as uncovered by in-house, as well as in some cases, customer is logging more bugs than your in-house team. So time to relook at your entire test strategy. So looking at the bottom table, you'll see 5 products for which we had collected data, N plus 1, N plus 2, in-house versus CRB data, the customer reported data, and the red text would indicate all these. I had collected this data for almost 12 products, but these are the 5 ones that had issues with the quality, and we needed to take urgent corrective actions. And this is what shows that the overall customer reported bugs were way on the higher side. Okay, now moving on to the next slide. Give me a minute. My sincere apologies. The slide deck that I had in presentation, it's kind of lost half the presentation data, and that's why I was scanning through it. But I have the paper open. I can walk you guys through with what I wanted to present. It has all the materials from here itself. So this is where we were. Just let me expand the screen. Okay, this is what data we have for the in-house reported bugs versus the customer reported bugs, and the ratio that we talked about. And the first three releases is where we see quite a drastic deteriorating trend in quality. Now, this is for the simple quality volatility that we had measured. Now, if we had to put in a weighted quality measurement, the trick was for us to get the blocker, critical, and a major version of failures categorically captured for in-house as well as segregated for customer reported bugs. And when we put in the same data, kind of a data for every release, we get a similar kind of a ratio. Our observation has been, since the irrespective of the simple volatility or a weighted volatility, the numbers are almost in the similar range. Going in for weighted volatility measurement would force you to mine through the data, segregate into different buckets, and that would eat up a lot of your time into analysis rather than taking corrective actions. Now, based on our analysis on just simple quality volatility, we were able to identify out of the 12 products, 5 products have issues. And we tell, okay, product 1 to 5, release N to N plus 2, we have issues. But what do we do with this data that we got? We got to know that product have issues. Some we know they're performing bad. Customer is logging more bugs than in-house detected. But what do we do? How do we approach this? How do we solve this problem? Let's park this thought on the sideline for a minute, and then now let's look at a completely different concept of test case effectiveness. Now, whenever a test case gets defined at design stage, a test case is built with a mindset that it needs to find one bug by exercising a specific code path or a series of code paths. Now, the moment I detect a bug using this test case X or test condition X, and there's a fix introduced into it, the code path which got exercised has been corrected if there was a problem with it. And now if I rerun the test case or test condition, chances of it failing is negligibly low. Okay. What would this mean? The code has become now immune to the test condition. So if I keep running the test case again, will I have the same kind of a value? What is the chances that it will find a bug again in the code? Once the code has been fixed for this bug, the chances of this test case again exposing a similar kind of a failure or a similar failure becomes very low. So this is almost as if to say that the test case effectiveness value is a decaying trend. Now, when we talk about decaying, at what rate is it decaying? It is almost decaying at the similar kind of equation which we are very familiar with, or some point in time we would have come across. It's called as a half-life equation. Now, this is a simple concept based on calculating radioactive half-life, and basically talks about how decaying the elements could be calculated once we know the rate of decay. So this is the standard half-life equation that you would see across, which is being referred across the calculations, a pretty well-established, thought-through conceptual formula, but using this for calculating our test case effectiveness is the interesting part. And N0 is the potential value of a test case when the test case was designed. NT is its test case, let's say 5, where T is the time interval after a certain period of execution when you want to know what is its true value. So NT basically is you have a test case which was designed at release 1, and after 5 releases you want to know what value this test case adds. So T is the time window, the execution cycles. NT would be the time at which you want to calculate the value of this test case. T half is the time for which time interval for which the test case effectiveness reduces by half the value. Now you could take it that it's a window of one release cycle, or you could take it as two release cycle. It completely is open for interpretation from whoever is implementing this model. I took the value of N0, potential to map one bug against one test case. So the starting point for me for a potential of every test case is 1. And what I do is the same formula. I use the first initial value as N0 as 1, T as in 1. What is the time window for which this unit of decay is measured? That is, or the unit of on exact time interval when I want to measure its effectiveness. So I keep it as 1. And this could vary from 1 to 10 to others release numbers that we want to measure the effectiveness. T half is the time required to for the decay rate. So I take it that every subsequent release, the test case execution reduces its value by half. So with this, when I plot the equation, this is a value, very interesting value that I get. At the start of the equation, at the start of the first time when the test case has been executed, its effectiveness is 1, probability of finding a test case is 100. Now, if it misses out this first execution, the second execution, if I run the test case, its probability effectiveness is 50%. Probability of finding a test case has reduced to 50% probability, and effectiveness has dropped to 0.5. Similarly, after 10 runs, this test case effectiveness has dropped to a negligible 0.0097%. And its probability of detecting a bug or failing, a test case failing, has dropped to 0.01%. Okay, so why this is an interesting piece is, after 15 releases, or after, even if I plot a linear trend of this, after 10 releases, the probability is less than 0.01%. If a test case has not detected a bug in the last 10 runs, what are the chances of it detecting a bug in the 11th run is less than 0.01%. If I follow a linear trend, by 15th release execution, now when I say release execution, within a given release, you may run this test case 10 times, 20 times. For simplicity's sake, let's take per release as 1 count. By the 15th release, same test case being run repeatedly without having a failure, the probability of it giving me a issue has dropped down to almost 0. Okay, so this is the time interval. What our observations have been is, after 10 releases, a test case is very much in a state where the code has become completely immune to it. This is a time window when you will have to revisit the test case, reprioritize so that newer areas could be added. Now, exception to the rule, if what would happen if my same test case, which has been passing consistently without exposing a failure, on the 12th run over here, it fails, which simply means that a stable code base has been tweaked. The same code which was exercised by this test case has now failed. It has been tweaked around. So we need to reset this count back to, either we could reset it to 1 again, or since a stable code has been tweaked around, if it has failed at the 12th run, reset it to 12 and again start the decay curve. Okay. Usually in sustenance releases where we are seeing very minor fixes that get released out to release over release, the expectation is that there will be no major code change. If subsequent runs are failing the same test, subsequent runs, a stable code start showing a behavior of a failure, you are in for unpleasant surprises where a major code change has occurred. Okay, so using this approach, we were able to bring in, understand which group of our test cases. You could apply this logic to either an individual test case. If you have a few thousand set of test cases, it would become a fairly challenging aspect until and unless you automate it to calculate the run rate and the current effectiveness. If you want to group it based on the module of your product or the most bugs that it has exposed, you will get a fairly stable effectiveness graph for each of these groups, test case or the test case groups. So now we have two data pointers. One, we know which products need help. We know which test cases need relook or review. And using these two informations, we need to now come to approach or start building our approach. How do we bring back our quality volatility to less than 0.2? Now, one of the easiest steps to incorporate during this is we need to write new test cases, review existing test cases. Now, writing new test cases, a traditional automation approach or a traditional teams approach would be build automation so that they are run extensively on all possible platforms and environments and so forth. Automating a test set is ideal way, but it's a long pole. It would take time. Easier, cost-effective fix is we introduced this is our approach, how we quickly turned around things within 2 releases. We introduced exploratory testing, and exploratory testing started increasing our in-house detected bug rates. And this simply meant better customer experience, customer issues which were reported started dropping for us. Now for this exploratory testing, what are the topics that we picked up? Basically, we picked up the last 3 to 6 release customer bugs reported. We started building use cases around it, and we manually ran through it at a much faster pace while the automation team was building through that backlog of automating it. This is the first change that we did. We changed this mindset. Second, we started with the test case groups, which have been almost running without having a simple bug exposed, deprioritize them and give the regression cycles more priority in the release cycle for execution. That's the second change we introduced. Design review by QA is one more feature we pushed in. We very aggressively followed this technique. This is what I was talking about. A best place to detect a bug is even before it's coded. And there is no point in having a code review if you have done a faulty code or a faulty interpretation. I wouldn't say a faulty interpretation by the dev, a different interpretation of the dev, and QA challenges that after it's coded, it's still a costly affair for me. If dev and QA could sit down in a room, which we did, and have a discussion on a feature implementation. What is the feature? What is the requirement? Not everything is written in a feature requirement document or a feature definition. We have to start defining. The QA could start defining what is this feature's definition of done, and start talking about this is our understanding. This is what we thinking from the persona of the customer, that this feature would be talking or working in this fashion. And these are the conditions that we would be testing. Now, if developer has a similar mapping, one-to-one mapping of the understanding, either he could correct himself right there before he codes in a different implementation, or he could put in a different interpretation of the requirement, and the dev and QA could come up onto the same page. So this helped us cut down a ton of issues even before they were introduced into the system. Based on all of this, when we started applying these changes for our release, this is what we could see. In-house reported versus customer reported issues, we saw this change coming up. For the same 5 products, for the same features that were released, for the enhancements that were released, with N+2, we started pushing in the changes. Now, maybe we are not in the most ideal phase. We are not able to bring ourselves below that 0.2 ratio, but we have dropped from 1 to 0.5 in the first product. We have been able to drop from 1.29 to 0.53 in the second product, and so forth. But we are on the right track. We are on the right track. We need to keep pushing further to see we sustain this mindset till our automation folks catch up with the backlog of regression testing being automated fully. So this approach, which is very quick for us, the quality volatility that we measure, clubbed with test case effectiveness, has been a very key factor for us to driving quality change. The biggest benefit for us is the quality volatility is very instant to measure. I could pull out this data right on the day of go no go meeting. I have Jira scripts which could pull out this data for me, and I can populate the data set, and I can go ahead with this. I have for example, if N+4 release go no go is happening, I will have all the in-house reported data all the way up to N+4. Whereas for the customer reported data, I would have only till N+3. So based on, and then for these four values, I would have calculated the ratios. Based on this trend and the ratio trend, I will be able to suggest, will this product have an issue in the upcoming releases? Basically, we would be using the more deeper the data set. I've been tracking this data for the last 10 releases. So I have, what you're seeing is 5 data pointers, but I have been having the data sets for 10 to 12 releases. So with that kind of a data set, you'll be able to extrapolate what would be the next point in the line would be. And the way, it's pretty simple extrapolation that we use, a linear extrapolation we use. And the ratio we could project a ratio number and say that product X may have a concern in the field, and that needs to be relooked. And this is based on the historic data. Now, this is where we go back and relook at the test execution for this product X and say that, okay, seems like it has been planned. So let's review the checks and balances that we have put in place so far, whether it meets the criteria. Again, we go in with the best case possible from our side. And the real truth comes out only after the numbers have been detected from the customer reported bugs. We do understand the indicator itself is a lagging indicator, meaning to say customer reported bugs have to be logged in to truly understand how good or bad the product has performed in the field. But there is a lot of data in-house that we could collect, as we spoke about it initially, code coverage, automation, all of it is good data, but not a true value to tell how much of customer bugs we may expect. Customer bugs count will only come after the product has hit the release. And in that sense, we need to collect historic data to project the next in the series. Are we capable of projecting 3 or 4 series down the line? That may be a challenge, but next immediate release, how we may fare, that easily to a fair degree, we can navigate that skill. And the deeper the data pointers that you collect in your sequence, it would become much easier for you to looking at the pattern. So these are some of our key takeaways that we see to measure QA effectiveness. You don't need a complex set or a complex system built in. Like, it would take effort for us to run code coverage. It's another additional churn that we'll have to do to understand code cover, set up that infrastructure, run it, and if it is low, to try to understand what we need to do to it. Code coverage, path coverage, conditional coverages. Though those traditional metrics are good, but we need not have to have that kind of a setup to start measuring quality for our products. We could simply start with the PCR measurement, very similar to PCR, quality volatility measurement, and we could get started with this. It's a fairly simple, easier way to move forward. The second approach that we learned from our entire exercise of understanding how quickly we could do. Now, if you are in a time crunched release cycles, like we do monthly release cycle for the cloud products that we have. And I cannot afford to spend a week mining the data or building up numbers. For me, customer logged bug count or customer logged data is a golden set. All of my success, it's one radar which tells all of the efforts that are putting in that is being guided in the right direction. So customer logged bug is the right gauge to say whether we all the efforts are fruitful. The another major attribute that we've uncovered to effectively detecting test cases is automation. Yes, it's a very much required for regular sustenance releases, but the true key to finding early bugs is exploratory testing, and much before they are being coded into the system. And that's through feature review, we have been able to cut down a lot of bugs that were uncovered. Now, this was a great learning for us. Another major piece for us is to understand and accept the fact a test case does become ineffective over period of time, or the other more easier way to put it across is the code becomes immune to your test cases. So every test case, irrespective of how it's been written, we need to review them timely, and we need to put in what time. That's where the test case effectiveness or the half-life equation will help you. Code becomes immune to your test case. Moving from test to pass, which is predominantly an automation mindset, to test to fail, which is predominantly uncovering issues kind of a case, or a more customer-centric use case design technique, will help you uncover bugs pretty fast. Once you understand that mindset, getting it coded to feed your automation backlog is the right way to go. So this way, we have been able to correct 5 of our products, and we have been able to drive quality changes into our group. And that brings into the last set of my presentation. Any questions? There's a question: who files the priority for the customer defects? For us, the customer files usually P1, P2. Absolutely true. For every customer logged bugs, all the questions are all the bugs are logged at P1. No doubt about it. Engineering, there is different escalation channels. The support looks at it. If they feel this is just a configuration change, they drop it to P2, P3. If engineering assesses it and understands the impact, they will readjust it to the appropriate priority. And we pick up after the bugs have been fixed. So yes, customer do log a P1, P2 bug, but engineering will set in the right priority based on the assessment that's been done. Okay, so no questions from the room. Thank you so much for bearing through me. My apologies that the slide deck had an issue. I don't know for what reasons, just jinxed it. I will upload the completed deck onto the website. You could refer it over there. It was much more colorful. What I walked through was a plain version. This is my contact details, and you could reach out to me if you're implementing similar change for your product series, and I would be delighted to work with you. Thank you so much. You have a wonderful day ahead. Thank you.